So who am I? I've been at Rackspace since October of 2011, so I've had 3 years at Rack, and most of this is talking about some of the experiences I had at Rack. Some of this is pre that, but it's mostly that. I'm a senior product security engineer. In the product security group, or actually now we're called security engineering, I think, we report up through the QE structure in product. So the bit of Rack that makes our cloud products, we work in that group with the developers and the other teams. And then the other half of me, I guess my bipolarness, I've been very involved in OWASP since 2008. I did a project called the Live CD, which has morphed into this OWASP WTE, which is a VM and a whole bunch of Debian packages to install application security tools. I like to refer to it as my gateway drug to AppSec, because I try to make it just as simple as possible, so if you have an inkling, you can get in the door easy and hopefully get hooked, because there's not enough of us. There's not even close to enough of us. But that's me. So, DevOps, CIs, APIs, oh my. So just so we're level setting, I don't really need to do this here in this venue, really, but DevOps, right? It's a combination of traditional, or it's trying to get away from the traditional throw over the wall development model where you actually have developers and ops people working together. Collaboration is huge, culture is huge, agile development with sprints and scrums and stand-ups and all that good stuff, and release coordination is a big deal, right? But we all kind of know DevOps, right? And anybody confused now? We're good? Right, okay, good. And then just in case I'd use these acronyms, this is what I mean by them. CI for continuous integration. I've heard CD used as both deployment or continuous deployment and continuous delivery. They're kind of the same thing-ish. TDD is test-driven development. And then API, application programming interface, right there. Done with all the boring stuff. Okay, so the problem. So cycle time for software is ridiculously short. Our most aggressive group at Rackspace in terms of pushes to production, code pushes to production, I think averaged 75 per week over the last year. So if you think you will have a testing window, it is really, really small and forget it anyway, right? So like, that's our most aggressive group, and there's a range at Rackspace, but generally speaking, like you will not have the traditional, I'm gonna waterfall approach and I'm gonna have a week to do my security testing. Like that just doesn't exist. And quite honestly, for most, particularly forward-thinking shops, anyway, continuous delivery is a goal, right? Time to market is huge, and you are fighting the business if you want to tell them no and be a roadblock or even a speed bump, right? Because you will lose. You have to convince the business that doesn't want to get to market fast, and that's not going to work. And so, I've already said this kind of, scanning windows are just not viable. They're done, right? You have to do something different. So, slow slide thing. More of the problems, right? Even in traditional waterfall shops, which is where I started years ago, there was hardly any time to test. My favorite story about this was I saw a Gantt chart of the software, this one bit of software going out the door, and I saw security testing. And I'm like, ooh, I got a line on the Gantt chart. And I looked and it said 0 days. So it was something, but it wasn't much of something, right? So like even in waterfall, which is what I was at that time, I was kind of doomed. So forget it. You know, DevOps and continuous delivery even makes it worse, right? Your 0 days becomes -3 days or something like that. You have to do some crazy time math. And then you have the proliferation of languages that you can't even do static analysis on, right? The Rubies and the Pythons and the Nodes. Like, talk to static vendors if you want to see them weep. Say, all we have is Node. What do you got for me? And they'll go, oh, have a squeezy, go to the next vendor, right? Because they don't know what to do with it. It's a hard problem to do static analysis on interpreted languages. And then even if you do have time to do the automated tools, you probably are seeing some sort of REST API nowadays. And I don't know of a really good tool that handles REST APIs well. Certainly if you don't produce something like a Waddle where I can actually programmatically figure out what methods you have, somebody has to read the FIND manual and figure out how to talk to that API before you can even try to scan it, right? So it's doomed, right? It's time to we should all quit now, go start drinking, and forget about it, right? Because we're doomed. Well, it's not really true. Like, we have to automate all the things. And what I'm going to talk about is automating software testing, automating operational infrastructure, so the software checking or hardening sort of status of operational infrastructure, and then automated security testing. Okay, first off, I think it's really important as AppSec people. I have a background. My first job out of college was actually working for an international telecom, writing software in Bryan College Station. For those who are native Texans, you know that's kind of a nowheresville. And oddly enough, all of our IT or all of our telecom was in Europe. So when I goofed up, I got a pissed off Belgian calling me at 2 in the morning because that's when he was waking up. I mean, so the point is, I started out life as a developer, and I think you have to do some sort of development if you really want to be an application security person. I mean, this is like a hard fact of truth, but I mean, if you can't talk dev, you're really behind the 8 ball. And I think it's time for us to not only do some dev, but think like a dev, right? Break your testing into little pieces, right? Like, figure out how you can do, I mean, that's what unit tests do, right? Your unit test doesn't test the entire app, it tests a piece of the app. Do the same thinking, or have the same thinking when you're doing security testing. And quite honestly, this is threat modeling. Kevin talked a minute ago before me. And I'm sorry, Kevin, I was eating lunch, and Jarrett Rame had a really small crowd, so I sat in his room. Both of them are my friends, so I want to be, try to be equal. But anyway, Kevin does threat modeling at Rackspace. He's fantastic at it. And that's a fantastic tool to use to know the really important bits of your app, right? You're going to be time constrained. So do a threat model and know the really interesting parts. And there may be some parts you just don't have time for, and that's okay, right? You're resource constrained, you have to do that. And then look at the time your tests take to run, and you have to break them up into short and long tests, right? There are some things that are quick and easy, and you can parallelize them, and you can put them into Jenkins or Travis or whatever, right? And there are some things that take a long time. And this is when you start talking about doing testing windows, right? The short test you can run kind of all the time, right? Takes 2 minutes to run it every hour if you want to do, whatever the frequency makes sense. Those longer tests, maybe you only run them weekly, and that's okay, right? That's certainly better than not running them at all. But you have to sort of break up the idea of not doing the everything test that takes a week. Do 40% of it that you can do daily, and maybe that 60% has to be weekly, right? There's some sort of split. But you have to really think like atomically about these testing parts. Oh, yes. And test code needs to be optimized. We can no longer write those like really god-awful bits of Python or Perl or whatever that just sort of work, and they're maybe slow and ugly. I remember one time, this was when I was pen testing, but I used a brute forcing tool that did a DNS lookup for every request. And I ended up making the DNS people call me and yell at me. So, oops, sorry. But I mean, there's a very unoptimized test. Like, why the heck wouldn't you cache the name lookup on the first one? Because you're just sending a whole bunch of stuff to the same thing. But this test was not written optimally, right? It was written very poorly. And then smoke test versus regression test, right? To me, a smoke test is it's fairly saying it's good, you must be this high to ride, right? Do those as frequently as you can all the time, right? And then full regression tests, yes, you have to figure out the right interval and do them at that. And I'll talk through more specifics when I get into what we're doing at Rack. Okay, so maximize what you've got, right? A lot of people have good testing, or whatever programming language you're using, there's probably a lot of security features that you're not even aware of or turned on, right? If you're using Django, why isn't the CSRF token turned on in the config? Like, that's a duh. You get rid of CSRF with one config change, and Bob's your uncle, right? These are like easy things that you can fix systemically just by really knowing your frameworks. Hopefully, Rackspace, I like to say, it's easier to tell what languages we don't have than do. If you're lucky to be a blah shop, right, in .NET or Java or whatever, you have an advantage, right? You can really get to know that framework, and you should if that's what you're facing. Oh, yes, from a testing perspective, make your tests easily repeatable, right? Because ideally, you're going to find something you're going to find a vulnerability, you're going to report it, it will be fixed. You will need to retest that in the future, right? That's the whole point, right? So if you don't make it easily repeatable, you're actually hurting you and the overall throughput of your team, right? So these tests have to be easily repeatable and easy to understand, right? Because I may test it today, and then come talk at a conference, and some poor guy back at Rack has to retest, right? And if he can't read or understand how I did the testing, that's not real useful from a team dynamic. And then make tests abstract and combinable. And this is what I was talking about, long and short running tests, right? You want to have a suite of a la carte tests that you can throw at apps and pick and choose menu style, right? I like these 3 and 2 of those, and a pie to go, right? Add those in to your testing. And think about the pipe, the Unix pipe. I'm a Linux guy. And I think the big thing about the pipe idea is you want to have tests that you can easily pull data from one into the other. And I'll show you later, we ended up with the workflow in the product security group, security engineering group, where we have one test feeding into another. We have an entire workflow going, and it's all based on the fact that I have A knows how to talk to B, knows how to talk to C. And I'll show that in more detail in a minute. Woo. Fun talking after a big barbecue meal. So I like this idea of test-driven security, right? So under the constraints of DevOps and continuous deployment or delivery, right? You have to be nimble, you have to be agile. And so test-driven design says your code works when it passes a test, right? This is the idea of like, I write a test and then I write some code and I don't have working, well, the test will not go green until I have working code, right? That's test-driven development. Test-driven security says you've met this baseline if you're green when these tests pass. Now, it's not a full security test. It's not an ultimate checking of all bits of the security, but at least you know that you're this high before you go out the door. And I think that's a key point. There's a lot of sort of security purists that say, oh, well, that only tests 50% of the use cases. That's terrible. Well, that's 50 more than I had when I didn't automate it. So I'm sorry, I'll take that change. So it's a time to mourn. We must say, traditional AppSec, if it ever existed, and it sure didn't exist long, it's gone, right? I'm an advocate for sort of changing the mentality of how we do AppSec. And we're gonna have to go through the 5 stages of grief, right? In the early stages, right, Agile is a fad. The waterfall was the only way to produce good and well-maintainable software. This is no, right? You may be there. You may have moved on to anger, right? There's no way I can test in that time frame. We're done. Like one more friggin' sticky note and I'm gonna lose it, right? I used to love, at one of the places I worked, we had the sticky notes up on the wall and I used to say, we are one aggressive cleaning lady from having our entire development process derailed, right? Oh, look at this, what did they do? I will clean this up. Oh, whoops, right? Bargaining, right? Well, I can test some of it in 2 days. I guess after it's deployed in prod, I could test it, right? You're getting to sort of get the hang of this, like you're learning to live with it, but it still doesn't feel good. Depression, right? After that launch, I updated my LinkedIn profile. And then from Aliens, for those who remember that movie, like, game over, man, game over. That's what I think sometimes. Like, oh, game over, we're done. Like, it's just a matter of time till we get popped and I get fired and I'll find another job, I guess. And then acceptance. So you should now be speaking to developers like, say, you know, when you're working on your Scrum, can you add a story to work on that auth regression we found in our testing, right? That should be the conversation you're having, right? Hey, we reviewed your deployment recipe and we have a pull request waiting for you to change how you do your deploys. You know, can you do that PR for us, right? That's how you should be talking to developers and DevOps people, right? SysOps people. That's how they work right now today. You should be talking their language. So we're going to fly through those 5 stages of grief, hopefully addressing how to secure infrastructure, apps and APIs, and securing code. This is my take on doing those things. So securing infrastructure. Hopefully you are automating how you do deployments, right? You have some sort of Chef, Puppet, Salt, Ansible, whatever the next cool something is in 3 weeks that has a .io address, whatever, right? You have something that lets you automate deployments in a sane and repeatable fashion, right? These are fantastic tools. Like having been a sysadmin at one point in time, I love these things. I wish they'd existed when I was a sysadmin because they're really, really cool. I don't have to like SSH the machine and VI something. And one of the powerful things let me keep going. So for example, Chef, right? There's a couple different deployment models of Chef. You have a system administrator who writes some recipes. Maybe it's hosted or private or whatever. You have definitions that know how to deploy different nodes, right? So I can say, this is a web server, and this is what it looks like. And I declare that in Chef or Salt or Puppet or whatever, and off it goes. So cookbooks, stacks, playbooks, what have you, right? These are the things that DevOps people are writing to do deployments. This is where you can actually gain a ton of traction as a security person, right? You should be spending time reviewing these things and understanding what's going on. Whatever, fortunately at Rack we have all of it. But whatever you're facing, hopefully it's just one thing, Puppet, Chef, or what have you. But this is where you can get huge, huge payback, because if I can be assured that when that API node goes out the door, it's hardened, I don't have to worry if they launch 1 or 40 or 1,000 of them. I don't care, because I've already reviewed this, and I know it's good, right? This is a place where you may have to go in and do a pull request and say, you know, I know this makes a functional API node, but you accidentally left, who knows, directory indexing turned on in Apache, and like, that's dumb, we shouldn't do that. Let's just turn that off, right? PR request, here's your change, add that into your recipe, we're done. And if you want to get extra bonus karma points, like push these upstream, because I haven't really done much of this. But I imagine if you look at the general publicly available Ansible cookbooks, playbooks, whatever, they're probably just enough to get it up, not really get it up and secure, or hardened, right? So if you want good Garmin points, start putting those public. That would be a good thing to do. The other powerful thing with Salt, Puppet Chef, Ansible, what have you, is you can group and tag servers, right? So I have this idea of this is a web node. I have the idea of this is a worker process or a worker node. This is a database node. This is a whatever, right? Because I have this tagging that makes the automation work, I also have a base, well, one, you can have a base set of security requirements for all the servers, but more importantly, you can customize and set policy, right? Each server with the database tag must look like this, period, right? And now you're actually tying policy to tags that are being used in whatever your deployment mechanism is, right? And you can verify against that. It makes life really easy. Yeah, map the tags to security requirements. Ideally, have a way to test against those security requirements, and you're golden, right? This is a huge change, because now we're not doing the, hey, it's your time for your monthly scan, and oh God, we found all these issues, and it'll be another month before they get fixed, right? They're just part of the process. Automated and repeatable, which is beautiful. Okay, the other aspect of this, an inspector. So, oh yes, for each group and or tag, right, hook the provisioning so that you know, okay, I just deployed a new API node. That should have caused an event that causes it to be scanned, somehow to be reviewed, right? This is the idea. Think about you're building a house, right? You have an architect that designs the house. You have a builder that builds a house, and you hopefully have an inspector that comes through and makes sure everything's sane. This is the inspector, right? This is the guy that goes in and says, yes, all of the, the plugs are 2 feet off the ground, and the plumbing is done with glue, and et cetera, right? These are just bare minimums, but not perfection. And that's another important point, right? If you want to go for perfection, you probably won't have time, and you won't be agile enough. But you can have multiple facets: security, scalability, compliance. You can roll all that into this inspector, right? And now, as you're doing deploys, a node goes up, you automatically check it, it's green, everyone's happy. Right? And as a security person, I don't even need to know about that really, unless it's red, right? So that's another cool feature of this. You are time constrained by default really in security, that's just life. So I only want to be bugged when I need to be bugged. I don't want to know they deployed an API node. I want to know they deployed a broken API node, right? Otherwise, I don't really care. I'm too busy. Agent, one mole to rule them all. So add an agent to your standard deploy process, and this could be something you write or something you buy. Ideally, you want it read-only, because that makes sysadmins much happier. Like, what is this thing that can muck with my system? That's probably not a good conversation to have with a sysadmin. And it just looks at the state of the system and can basically narc on that box, right? It just reports to a mothership what's going on. Hey, this hasn't been patched. Oh my goodness, I'm running an outdated version of Nginx, right? Those kind of things. And it wouldn't say it's outdated, it would just say, hey, I'm running version X, right? And you could do the math to figure out it's outdated. Put that into a dashboard, right? And now you can do things like say, oh wait, there's a new vulnerability in Jenkins, and we have a lot of Jenkins out there. Well, I know all the Jenkins because they're tagged. And I can do a policy that says Jenkins must be greater than X. And all of a sudden, all the servers that are not outdated go red. You know who to go track down and find. You can also play the game of like, gee, that's funny, this group got their servers fixed yesterday, and you guys still haven't even touched them. Hee-hee, right? A little bit of politics and political pressure is not a bad thing, right? And then you can watch that board go green. It's a really powerful tool. You can roll your own. There's a vendor called Cloud Passage that makes an agent that does this and a lot more. Mozilla has this project called MIG. There's an open source project called Linus that'll do hardening checks. There's a bunch of different tools out there for you, but this idea of being able to have something let you know that something's gone wrong, right? That's much more powerful than the quarterly Nessus scans or what have you. And then turn vulnerability on its head, right? The traditional way of doing vulnerability management is I scan at some interval, I print a report, and I head it to system people, and they hopefully go fix it, right? That's the sort of model that we've been doing for years. Well, that's really not very cool, particularly from a sysadmin or from a security perspective. If you have a decent handle on what technologies you're using, you can take that and basically subscribe to all the vulnerability or announce or security lists for those key technologies, and then let your guys know ahead of time, hey dude, today, Nginx released a patch for this awful vulnerability. You need to go get it, right? Let's go patch. It's completely 180 on the usual model of, gosh, that's been out there for 6 weeks, and I'm finally scanning it, and by the way, it's out of date. You can roll your own. I did this for a while at one place where I just had a Gmail account and some filters. And it works okay, and it's awfully cheap. I mean, that flies right under the budget. Quite honestly, Secunia Vim has another product that'll do this for you too. They have like 40K plus products. They'll scan and keep track of you if you don't want to do the baling wire and duct tape Gmail thing. But it reverses that standard, scan and report methodology that I just think is broken. And it's not a good conversation with sysadmins. If you're trying to make friends with them, like telling them, hey, your baby's ugly, and by the way, I waited a month to tell you that, that's not very cool. Not to mention, if it's a really bad vulnerability, it's like, oh God, now I go to panic mode, right, and run around and, what do we do? Instead, you're proactive. Like, hey, there's this ugly thing that came out today. How are we going to handle this? When's your next deployment? What's your next release? Oh, you're going to release on Thursday? Well, it's Tuesday. We can wait 2 days. No one's going to die, right? Those are the conversations that are much better to have with the people you have to interact with as a security person than the, oh God, run around and panic. I'm getting old. I don't like panicking anymore. It's not cool. So let's talk about securing APIs and apps. Okay, yeah, PDFs are but bugs are better. Like if you're working, particularly I'm internal now. If you're a consultant, you will still have to do PDFs, sorry. But if you're internal and you're working with the developers, you should be submitting bugs. They should never see a big fat PDF from you. Like it depends how you want to do it. Like all the XSS into one bug or each one have a bug, that's your call. That's kind of a semantic thing, it doesn't really matter. But that it's a bug, right? Your security findings should be no different than the functional findings they get from whatever your quality QA, IV&V group is, right? It should just be the same. This is how developers deal with things. There are bugs, they fix them, right? Shouldn't be a radically different thing for security. Bonus points, if you have a bug tracker that has an API, because guess what you can automate, right? Now I can submit a finding, boom, it's in their bug tracker. Done. Security issues around this, if you are just doing bugs, which is what we do at Rack, you have to be aware of death by backlog, right? Oh, thank you for that bug. We put it in our backlog and it'll sit there forever. That is a problem. You can get some decent traction if you do occasional security sprints. If you can talk the team into saying, look, this next sprint, we need to just handle these security bugs. You got a pretty good backlog of them. Let's just knock all those guys out. We'll have one of our team members help you. If you need it, let's do that, right? And a lot of this is just learning how the teams treat issues, right? You need to understand how an issue, functional or otherwise, is handled by the team you're dealing with, and then make sure your system doesn't interrupt that, right? You want to kind of gracefully slide in those security defects. ThreadFix is a really nice tool for pumping metrics, or for collecting metrics and also pumping your issues into issue trackers. It sort of sits in the middle. You can put in findings in there. It'll tie into various bug trackers, push the issues directly in there for you, and also tell you when they get closed, which is the other side of this loop. You kind of need to know when those things get closed. And another reason why an API is super handy. Okay, for the reticent, we need to nag a bit. This is something we did at Rack that I think worked really well. For each level of severity of our findings, we attach an SLA. And the SLA is, well, the crucial aspect of that SLA is it isn't having it fixed, it's to have a remediation plan in place, right? Because when you find a vulnerability, a lot of times you don't know where that team is and their production schedule and when it has to push and how ugly it's going to be to fix this bug, right? But at least we need a plan, right? So we establish different SLAs based on the severity of the bug on when we have a remediation plan, right? And we can have some back and forth with the team and decide what makes sense and be rational about it, but at least we know, look, there's a plan. And we know that on, what is it, November the 7th, you will have a fix in place, whatever. That's a plan, right? And then you age all the finding against these SLAs, right? Because eventually a plan means you have a date, at least a tentative date, but a date. Then you begin to politely warn people when you get close to those SLAs. Hey, you're 5 days out. Hey, you're a week out, right? And if they get really close, you can kind of play the hard game and walk up the org chart, right? First you hit the project manager or the dev manager maybe, then the project manager, then their director, and then the VP, right? You just start walking up the org chart for those people who don't want to play the game. And then bonus points if you get a dashboard, right? Because you can start having this of like, gee, this one team is the one that's always got a high level of bugs. I would say, though, if you're going to do this, particularly walking up the org chart, make sure you have management buy-in for that, because that can get pretty political and heated, right? You don't want to start walking up the org chart without the org chart people knowing this, because you will not make friends and influence people that way. So make sure management's cool with that before you go down that road. And then reporting, our favorite thing. So reports equals findings plus automation. So Pick a markup language, I don't care what it is, and write your findings in that. Most of your technical tester guys like me or whatever, they like writing text. I like writing plain text. I like a simple editor. I don't want to open up Word. I just want to write stuff down quickly in a text editor, right? Well, fine, if you have a markdown, you can make that simple text into whatever you want, right? Things like pandoc will take markdown or ASCII doc and make PDFs or doc files or whatever you want, right? Done. So don't spend your time trying to make the pretty report as you're recording those vulnerabilities, just write it in a markdown. The other cool thing you can do with that markup language is take that markdown language, read it in, and shove it into a bug tracker, right? Because it's parsable by design. And then for testers, you inevitably will have boilerplate text, right? Cross-site scripting is when blah, 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 blah. And I've written that a gazillion times in my testing career, and I shouldn't have to write it more than once, right? So use boilerplate items so that as a tester, really all I should be reporting is the systems that had it, an example or a specific case of where it is, and then you really need to have that impact written in the context of that app, right? Because cross-site scripting in app A may not be as bad as cross-site scripting in app B. But the references and the what it is, all that's boilerplate. Like, don't write that more than once ever if you can avoid it. And then take your new findings and turn those into templates, right? So you do have to write the first time you find cross-site scripting, but the second time you just reuse that boilerplate, done. And then write a web app, or, well, if you want to, use a web app or something to keep it consistent. We started with Dratis, or Dratis, however you say that tool. The problem is that doesn't constrain you how you do markup. You have to trust everybody to write markup consistently. That's not an absolute position, so we ended up writing our own web app, where the developers, the product security team can type in their issues, and they automatically become templates for the next time we have that issue. Done. And we're working on a system to make it blessed, right? So those things that become templates have to be approved by a senior person before they actually are used by junior people. But that's all something you can do with the template, right? So now, like, cranking out vulnerabilities is fast, right? Put them into a web app, they get dumped into the bug tracker, and done. Very little action, very little interaction with other systems, and copying and pasting and all that mess that you used to have to do when you had doc files and junk like that. Okay, leverage existing consistencies. So this is just keeping your eyes out for anywhere that you can automate things. And wherever they are, find your paper cuts and write simple, stupid scripts to get rid of those paper cuts. So we don't do this at Rack, but I did it previously at another place where I did pen testing. We had a standard layout of how we saved the files per engagement. We just created a zip of that layout, and you'd unzip it and rename it the client name. Done, right? My file layout is the same every time. New client, copy the zip, unzip it, rename the directory, the client's name, done. Push those to the file server when you're done testing. Now everybody's client directory structure is all the same, right? I can go into mine or his or anybody's client directory and find where the nmap results are or what have you, right? And that's a stupid little thing, a zip file, but it saved ridiculous amounts of time. And then automate the directory, so the drudgery. So automate bug finding and submission. I already talked about this. If you have an API to your bug tracker, you should be submitting with that, right? You should push a button and the bug should go in, done. Automate PDF report generation. We do this every once in a while, mostly for political reasons at Rack. I have been in Markdown. We use ASCII doc. I just convert that ASCII doc to PDF and I have a report, done. Like, I didn't have to do anything but pull all the findings that are already in ASCII doc, glue them together, and turn it into a PDF. Report done. Oh, API documentation to a basic test harness. This was a brilliant idea from one of my coworkers, Michael, who, for OpenStack, they don't produce waddles. And waddles are a way to say, these are the methods with this REST API, right? So we didn't have a good programmatic way to write methods to talk to different APIs. But the documentation for OpenStack is generated, which means it's consistent. So we actually wrote a screen scraper for the OpenStack documentation that would take that screen scrape and turn it into stub methods of all the method calls of that API we were testing. Did it work? No, but it gave me boilerplate code in 30 seconds or less to do all of the methods for whatever API we were testing. I mean, that's a huge savior, right? Because we were just manually one by one, okay, do the create server method, okay, do the delete server method, right? Done. And then, well, another great one too that he did is we found, like for reflective cross-site scripting, you want to have a test harness for that. It's called an HTML page that you can mail the developer, right? Reflective cross-site scripting is clicking on a link and badness happens. Well, just give them a web page, a static web page with links. Here's your test harness. When you don't get alert windows, come talk to me. Right? I mean, there's simple little things that are sort of these paper cuts you can use to really speed up your process, because you will never, ever, ever have enough time. Oh, sec tool output, combine and convert. So I've written a couple parsing tools to take the output of security tools and convert them into our finding blocks, right? So I run Nessus, but I want it to look like my finding blocks. I take the Nessus XML, and bam, I generate our finding blocks. Yeah, you have to tweak them a little bit, but not that much, right? Much better. And you'll get like a huge win from the team, because they don't see this is your Nessus report. Oh, and this is your app scan report. Oh, and this is your this tool report. And oh, this is your this tool report, right? You just get a report. Done. It's a huge, huge, huge win. Okay, securing code. Where am I in time? I think I'm doing good. Perfect. So start with the developers. These are the dudes and dudes that's running code for you. So when you're running a finding, it has to be detailed enough to be able to reproduce that issue if you haven't seen it for 6 months, right? If you're not running that much detail into the findings block, you're doing yourself a disservice, right? And this is mostly, actually, honestly, to protect the security team, because I may test it and someone else may have to reproduce it and retest it. And if I don't give them enough detail, they're gonna have to relearn the wheel, while I'm out of town or what have you, right? This is just good common sense. You should have enough detail for QE to test it and the developers to find and fix the issue. And I saw a report one time, I loved it. It was, what was it? I'm trying to remember this, yes, that was it. Oh, I love this one. A pen testing report from a company that I was doing a re-pen test of them. And they said, there is lack of entropy in your session. They had this beautiful 3D cube, right? Cool 3D cube. And they said, this is what your session data should look like. And there's all these random red dots in this beautiful 3D cube. This is what yours look like. And it was an empty cube. Well, that's not very cool. And it really doesn't mean much. Now, what had happened was they were incrementing by 1 the session ID, right? Session ID 1, session ID 2, session ID 3. So it's really 0 in entropy. But this beautiful, cool 3D cube graphic was useless. It actually was even worse, because like a developer's like, we got nothing and I need red dots. How do I do that? Right? I need more red dots in my program. Oh, crap. Like, it's just useless. So you need to be able to speak specifically to developers on things that they know how to go fix, right? And then, I preempted myself. I already did this. Quick and dirty scripts to reproduce issues, right? Script to abuse an API. So there was one issue I found in an API at Rack where if I sent this one really crazy malformed request, it would die, right? And I wrote, it was, 20 lines of Ruby or something to do this, right? Simple thing. Well, I handed it to the developers. I'm like, look, dude, keep running this until it breaks, right? When it stops breaking, come get me and I'll retest. Right? And it's a silly little thing, but it made a huge difference. The development teams actually like that, right? Because I don't think developer teams hand back things and say they're fixed when they know they're not. They've honestly tried to fix them. They just may not have the background and the perspective to test them like you do, right? So let's give them some help. And I already talked about this, right? Reflective cross-site scripting. And then earlier today, James Wickett talked about Gauntlet, which is another fantastic tool to do this automation. And once the findings start flowing, you will get a lot of trading requests. This has happened in 2 different places I've worked at internally. You start making findings, and all of a sudden the developer's like, how are you finding this crap? And I don't want to do this. Like, how do I fix it? Well, this is cool. Like, I'll gladly go talk to you now. Let's go have a class, all right? Let's make this stop. And then cherry pick what you look at, right? This is another place where threat models are your friend. Find the weak, unclear, or suspicious areas. A lot of times when you're doing threat modeling, you'll get these parts of it they can answer very specifically. Oh, we're using Django 3.2 on they'll give you all and what's this thing? It's the worker node. Okay, what about the worker node? It does work. Okay, well, I know what I want to test. I want to test the worker node because this guy doesn't have a clue what it is, right? That's the kind of thing you want to look out for in threat models. And then connections to external systems, right? Or any place where you're doing format transitions. These are places that are hard to do when you're a programmer, or places where you're going to make incorrect assumptions. I will always get the right formatted data. I won't check it. I'll just convert it and go, right? And then you have a bug or a security issue, right? Those are areas to look at, and you can get this if you have a threat model. The other thing is once you've identified these sort of spooky areas in a threat model, you can do things like flag code changes in those areas. So that worker thing I talked about earlier, any code commit in that area gets flagged. And instead of our normal +2, which is PR request, somebody has to go and +1 it, somebody else has to go to +2 it, right? And then it gets committed. Now it's +3. Like, I haven't had a security review of this, absolutely, but I've at least had 3 eyeballs look at it before it gets committed. And as a security person, I can go look at that because it's red flag, right? If I have the time or if it's spooky enough or what have you, right? Use the search features that you have on whatever code management you're using with. I mean, you can find amazing things with like grep and look for exec, which is sad, but still true. I mean, even silly things like that work. And then the biggest thing, and I think I say this later too, is make these systems organic, like that they can grow over time. Start with a list of problematic methods. We've had 10 different people make bugs in this method, using this method in our language. We're just gonna start flagging that. Because if any code changes happen around that, I wanna know, because we nub it all the time, right? But you start with 1, and then you have 2, and then 6 months later you have 12, right? But that's the kind of system you wanna build. You don't wanna build the system, you wanna build the system you can add to over time. Because you will never have time to build the system, but you can build one that you can keep adding bits to. That was a huge change of mindset for me. I always wanted to build the final super system, and I never had time. And I decided that's a joke. And I'm never gonna do that anymore. I'm gonna build systems I can keep adding to. False positives, yes. Never, never, never have a false positive. I would say that 1 false positive is worth at least 100, probably 1,000 valid bugs to a developer, right? You already, quite honestly, being the security person, going in and talking to the developers are on your back foot in terms of them believing you. And if you give them a false positive, you're already in the, oh, this is an idiot guy. I don't want to talk to him. He doesn't know crap. Stupid security people, right? Like, no false positives, please. It's so hard to get cred points with the developers. Giving them a false positive is asking them to start ignoring you, right? It's kind of unforgivable in my mind because if you're doing a Nessus scan and you're just shipping it to the developers, like, I can probably train a monkey to do that, to be blunt, right? I could probably train my 10-year-old kid to do that. Like, your value add is the fact that you ran that tool and you verified all those results and you're really dang confident that they're actionable results for those teams. If you're not doing that, like, why are we giving you a paycheck, to be blunt? I mean, that's like, I don't understand. Like, any idiot can run Nessus and click next 5 times and print a report. That's not hard. And then stick to differential code analysis. This is where you sort of take your threat modeling and your scary parts and then do code diffs. Because if you're looking at code diffs between commits, it's pretty easy to see if something in there changed that's important. Like, the scope of that work is hopefully 20, 40 lines of code or less, hopefully. Big commits, maybe more, but whatever. Right? You can easily sort of get an idea if you even need to worry about this. But doing this sort of differential analysis is huge because it lets you quickly tell if I care about this commit. And if you're having a lot of commits, you kind of have to do that. Where am I at? Oh, that's 5 minutes. OK, cool. Oh, I need to hurry. Oh, crap. And you need to build points with the cred points with the dev teams. Oh, quiet is better than wrong, right? Hire and befriend developers. Speak their language, not securities. We heard that already today. Suggest requirements, not implementation. This is a huge, huge thing, right? I don't really care, this is an easy example, if you use Tripwire or any of the other like file integrity management tools. I don't care. I just need file integrity, right? So I'm going to tell you, you must have file integrity on the server. I'm not going to say you must install Tripwire, right? Because maybe for religious reasons or whatever, that ops guy hates Tripwire. Well, at the end of the day, I need file integrity management. Done, right? I don't need Tripwire. So that's a huge thing. It avoids the religious arguments. Oh, and if you can't get language-specific mitigation suggestions in the language that they're written in, make sure they're generic, right? Because if you give a Python guy Java code examples of what's wrong, you just might as well have slapped him in the face. Like, they just won't listen to you anymore. Don't do that. It's bad. This guy's such an idiot. Doesn't even know we wrote this in Python. What a freaking idiot. And the other cool side of the continuous integration and deployment is fast deploys mean fast fixes, right? So yes, it is scary because code is getting out there all the time. That also means when you find a problem, if you can communicate it accurately and intelligently to the dev team, you can get it fixed really quick, which is kind of cool. It's actually really cool. Like, we had a group we were testing with at Rack and found an issue, hit them on IRC and said, dude, there's an issue with X, Y, and Z. The guy said, cool. Well, how did you do it? Here's how I did it. And he said, OK, cool, thanks. OK, whatever. Go back to testing, ping on the IRC. Hey, what's up? Hey, it's fixed. Dude hadn't even written up the finding yet, and it was fixed. So we ended up opening and closing a bug. Like, that's awesome. That's really, really cool. Oh, yeah, and if you are doing this stuff at speed, you have to retest really quick, obviously. That was easy. The guy just done the test. So what are we doing at Rack? In 5 minutes or less. So, come on, slides. There we go. So we have everything, Chef, Puppet, Ansible, Salt. What we do is, with the teams, we review their deployment scripts, right? Look at their Salt, Chef, Puppet, Ansible, whatever. We'll validate them with the external vuln scan, so we'll have them pop a node for us and do a vuln scan of that and make sure it's sane. And we'll recheck, do rechecks if we have any bugs, right? If we go, oh, wait, you forgot to turn on this configuration setting, they'll turn it on, we'll recheck, right? Until we get a blessed sort of config, and then we're done. Iterate on that until no problems. We're using Cloud Passage in a couple of places as a mole. We've had a couple other one-off agents, too, for some certain circumstances. And we've been doing threat models for a long time. If you saw Kevin's talk right before this one, we have, how many is it, 70 some odd?
106 documented and 73 complete.
There you go. And he has them all tied together. So you can do like the bouncing ball through our cloud. This talks to that, talks to this, and you just follow the bouncing ball. It's awesome. Securing apps and APIs. Our production workflow is, we have one of our team, sorry, it should be security engineering now, but we'll just say product security team finds an issue, we document it in our test tracker app, we push it to Threadfix integrates with bug trackers, and we drive metrics off the, actually this is incorrect, now we're driving metrics off the test tracker app. We bypassed that one thing. But that's our workflow. I mean, most of these steps, excluding finding an issue and entering, are automated, right? These last 3 steps you don't do anything for. They just sort of emerge out of the system. We are currently re-implementing our neg script because of issues to remind people that, hey, they got old bugs, excuse me. And then ASCII doc is our markup language of choice to do findings. And from there, you can create HTML or PDF or doc or whatever, right? And since we're pulling them out of a database, there aren't parse errors with the ASCII doc because we're generating it out of the database fields. And then securing code. We use Veracode for static analysis. It's nice because it's self-service for the dev teams to go push up your code. We use Jenkins integration. I think we wrote the original one and then gave it to, the original Jenkins integration was written by an internal team at Rack that Jarrett Rain was part of before I got there. And then we gave it to Veracode. And then we're using the API automation, or the API of Veracode to pull down findings. And then they go into our workflow just like a normal manual finding. We produce detailed finding blocks, and we will try to do ad hoc scripts. We're doing training. We have e-learning modules. We do work with devs daily. I've been loaned to the container team since January of this year. And we have DevOps or dev days where we'll go out. The team will go out and like hide in a conference room and knock out tooling, because if you don't make that time, it'll never happen. That's been a big win. Takeaways, key takeaways. Ooh, I'm good on time. Woohoo. Automate, 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 like find the paper cuts and program those away. And a finding workflow, you need to figure this out and optimize it. Ours is really fast, and it's been a fantastic thing. I hated this when I was a pen tester, and this has really been one of the best systems I've interacted with, and it's nice. And create systems that can grow organically. I already talked about this, right? You'll never have time to write the system, but if you write the system that's easy to add to, you will add to it over time. I need 5 minutes to add a new check to this thing. That's easy, right? And then use your finding blocks as templates for the next time, so you don't have to rewrite all that bloody awful boilerplate. And learn to talk dev, right? You should be saying, hey, I sent a PR request for your salt stack. Can you commit that for me? Right, as opposed to, that's bad. Here's your PDF. Right? That's not a cool way to talk to devs. And then I have to have a Machiavelli quote, right? Whoever desires constant success must change his conduct with the times, right? And I think we have to. I mean, I think if we want to be successful security application security people, we have to. We have to be much more like dev teams and be that agile. Because we won't convince the business to slow down, period. Like, that just won't happen. And that's it. And I'm good on time. Yes. Yay. I wasn't sure there for a minute.